Hi students, in this video we're going to look at how to draw and create and read histograms. So after watching this video, students, you should be able to organize data into a frequency distribution table, or organize continuous data into a frequency distribution table. Use that table to create histograms and display continuous data, then also analyze histograms to help answer questions. Alright, so there's a few things to recall. So first of all, we need to remember what continuous data is. So histograms can only really be used for continuous data. So it's important we remember what that means. So continuous data can be any number within a range. So, or put another way, continuous data is measured usually with some piece of equipment, and it can be made more and more precise with more fine-tuned and more accurate equipment. So the best way to think about continuous data is, can you make it more precise? Can you keep adding decimal places and get a more accurate reading? If you can, it's continuous. You should be able to remember how to draw frequency distribution tables, how to draw bar graphs, and also remember every graph needs SALT. A scale makes everything fit, axes that are evenly spaced, labels for your axes, and a clear informative title. Right, so histograms are used to display continuous data. So they look very similar to bar graphs, but the thing is there are no gaps between each column. This is because each column represents a range of values. So for example, in the histogram here, this bar here represents in the range of between 100 and 150 words that the student's written down. He had to do that 5 times in lectures. So we don't know exactly what number of words he wrote down, but we know that he wrote between 100 and 150 words in 5 of those lectures. So there's no gaps in between columns. So you've got 0 to 50, 50 to 100, 100 to 150, and so on. We do have a gap in this column at the end here, but that's because there were no times that this person wrote between 200 and 250 words from their lecture. Alright, so we've got some data here showing how long a set of A4 batteries last in days, and we have to organize this data into a grouped frequency distribution table. So in our grouped frequency distribution table, we basically have our range, and we will just tally how many times, well, we'll just tally the number of data points that fit into each row. So for example, we've got, well, another thing to add as well is our bins, right? Our rows, our columns, they're all the same size. So they all have a width of 10. That is really important. You can't have some histograms that are really wide, some columns that are really wide and some that are really narrow. It's best that they're all the same size like these ones are. Alright, so we've got 2 8s, 170, 160, 100, 2 90s, another 100, 170, 2 80s, 190, 175, 160, another 70, another 80, 200s, 60, 2 80s, a 90, another 80, and a 100 and a 70. So in our frequency, we can just add those up. So we had 3 between 60 and 70, 5 between 70 and 80, 8 between 80 and 90, 4 between 90 and 100, and 5 between 100 and 110. And that's how we create our frequency distribution table. Just counting up our scores and tallying them up into those different bins or column widths. Alright, so if we've got our frequency distribution table here, and let's say now we have to create ourselves our histogram. So our first step is to make sure we've got a good scale. Our scale goes up to 9, which is good because our maximum score is 8, and our columns are all evenly spaced apart. They all go up in tens. Now what we need to do to start off our graph, however, is we need to include this little squiggly line at the start, because according to our graph we should be starting at 0. Right? And then from 0 we should be evenly spaced apart from that. But the thing is, we've skipped a heap of numbers between 0 and 60. So to show we're skipping a heap of numbers, we draw that little squiggly line to say we've skipped a bunch of numbers between 0 and 60 because, well, we haven't got any data for those numbers, and having a big empty space on our graph is not helpful. All right, so we can then just draw our bars. So between 60 and 70 there were 3. Between 70 and 80 there were 5. Between 80 and 90 there were 8. Between 90 and 100 there were 4. Between 100 and 110 there were 5. And so there's our data, and there's our histogram. So all the columns are touching, and we're just measuring how high each column is based on its frequency. All right, so then we need to, so we've got our scale right, we've got our axes right, we've plotted our data. We need to add some labels. So on the bottom axis, we've got our battery life, and the units are in brackets. Right, so when we read 80 and 90, that refers to 80 and 90 days. We've got our frequency measured on the y-axis, as we normally do. And then for t, we need our title. So we've got the battery life of a certain band of batteries, and that informs us about our graph. Alright, so students, after watching this video, you should be able to organize continuous data into a frequency distribution table, create histograms to display data, and then be able to read histograms to help answer questions.